The greatest integer function. So the greatest integer function is what it does is it takes a look at your input and it says, let's return the value of the integer the greatest integer which is not bigger than x. So what's the biggest integer which won't be bigger than my input? So let's take an example here. Let's think about the greatest integer function applied to 5.1. Well, what's the biggest integer that isn't bigger than 5.1? 5. So when we graph this function, and we're mostly concerned with positive values, when we have positive numbers, what is this doing? It's essentially rounding down. So if I think between all values between 0 and 1, it's always going to be rounding down the greatest integer which is not bigger. So let's take some other value, let's say 0.5. The greatest integer which is not bigger than 0.5 is going to be 0. So if I'm graphing my function, I know that I'm going to be at 0 for all values in between 0 and 1. What happens when I plug in 1 though? When I plug in 1, we notice that what's the greatest integer that's not bigger than 1? Well, 1 isn't bigger than 1. It is its own greatest integer function. So when I get to 1, my value is no longer 0. I will jump to the value of 1. And you'll notice that for all values in between 1 and 2, the greatest integer which is not bigger than any of those values is going to be 1. And so I'm going to continue along that way until I get to 2. When I plug in 2, the greatest integer which is not bigger than 2 is going to be 2. So I can't have value at 1 anymore. I'm going to jump up to 2, and that's going to continue until I hit 3. And so it's very important to remember that I'm going to have these points of discontinuity, where I'm going to have a point where all of a sudden the function jumps to a new value. Okay, and so I designate that by using an open circle that says there is no value at this point. And so this, you'll notice, it's kind of like rounding down, right? So any value between 1 and 2 is going to be rounded down to 1. Any value between 2 and 3 is going to be rounded down to 2. And now I want you to think about, how could you make this a round up function? Meaning, let's say I was between 0 and 1 and I wanted everything to round up. I'm between 1 and 2, I want everything to round up to 2. Well, what you can use this function again. You can use the floor function, and you can add something every time, right? So think about all the values between 0 and 1. What could I add to it so that every single time that I compute it, it will round up? If I add 1, let's think about what that will do. Let's try 0.1 plus 1. Well, that's 1.1. What's the greatest integer that is not bigger than 1.1? And that, of course, is going to be 1. When I get to 1, 1 plus 1 is going to be 2. So the greatest integer that is not bigger than 2 is going to be 2. So I have an open circle there, and I'm going to move up to 2. And the same thing will happen here, right? Any value that's between 1 and 2, if I add 1 to it, well, any value that's in between 1 and 2, adding 1 is going to be a value that's in between 2 and 3. Any value between 1 and 2, and when I add 1 to it, is going to be a value that's in between 2 and 3. So it will round to 2. And so I could continue this. Any value between 2 and 3, when I add 1 to it, will be a value between 3 and 4. So the greatest integer of any number between 3 and 4 that isn't bigger than that number is going to be 3. So we see how we can use the floor function to either use it to round down or use it to round up, and we can apply that to a lot of real life situations.